So can you hear me? Call on your mic and speak.
Good afternoon, everybody, and welcome to our session on trees outside the forest, agroforestry and urban trees. You have noticed probably in other sessions that it's sometimes a relatively wild mixture of topics, because it's not always easy to bring these topics together under a common title. But the common title here is trees, wherever. My name is Christoph Klein. I'm from Göttingen University, and there I'm a professor in forest inventory and remote sensing, and very much interested in trees. And I'm very happy to be here to share this session. It is so that the first presenter who wanted to join in online cannot be contacted. So for the moment, we assume that he will drop out, and we would like to start with the second presentation, which is from Mr. Tao Jiang. He is from Göttingen and working on trees in urban environments and doing interesting studies on monitoring them. Tao, the floor is yours. Please come here and take the microphone. You have 10 minutes like the other presenters as well, and then we have 5 minutes of discussion. And as we have lost the first presenter, we are quite flexible and relaxed in terms of timing. But please try to adhere to the 10 minutes so that we have time for discussions.
Thank you, Christoph. Hello, everyone. Can you hear me? Good. Good afternoon, everyone. I'm Tao from University of Göttingen, and I'm happy to meet you all here today. So the topic of my presentation is the effects of the urbanization on trees outside the forest. So I'm sure you guys all know about the concept about the trees outside forest. These trees can be found in the different landscapes, like in the urban area, in the rural area, and of course, the space in between. So the research questions we are exploring here today is, what are the differences between those trees and how urbanization affects them? So we start to answer these questions. We first select a study area, which is a research transect running in Bangalore, India, running from the urban area to the rural area, which has size of the 5 kilometers wide and 50 kilometers long. And above this transect, you can see some examples from the different regions. And the image we used for this study is the world view 3 image, which has a resolution of 0.3 meters. So the next thing we need to do is to map each individual tree along this gradient. So here is the methodology chart, which consists of 3 parts, highlighted with the different colors. So in the first part, we use a deep learning model to detect each individual tree with a bounding box. And in the second part, we build an elementary model to predict the DBH of the trees using the crown diameter. And in the third part, we produce some maps, including the tree density map, tree crown cover map, and the base area map. So now let's dive into each part in more detail. So in the first part, the deep learning model we choose is a detection transformer. I guess you guys all heard about transformer from the ChatGPT. Yes, this transformer can also be used for the image processing. Here we use it for the tree crown detection. So to train this detection transformer, we labeled around 330 image batches. That results in 23,000 bounding blocks. After validation and training, we achieved an FE score 74%. And then we apply this trained model along the gradient. So we can detect each individual tree with the bounding box, which you can see from the right. So this is some prediction results from the different regions, the urban area, rural area, and transition area. If you want to know more about this dino stuff, you can check out the follow link, paper link. So in the second part, we try to build a logic model to predict DBH, because what we did before is just to detect the tree crown. Now we really want to know what happened beyond the canopy. So we analyze the field inventory data using the 75% of data for the training, for the modeling, and the rest for the testing. So we find a quadratic function, which you can see from that curve. It is the best fit for our data, and that achieved a very high accuracy on the tested is the data set. With these two, now we need to map the trees along its gradient. But before we do that, we need to divide our research region into the grids, which has size of 100 meters by 100 meters, which is exactly 1 hectare. So the first, we need to estimate the tree crown of each individual tree by using inscribed ellipse. And then we merge those polygons within the grid, as you see, to get the total tree crown area. By counting the bounding box within the grid, we can get the tree density per hectare. And using the allometric model we built before, we can get each individual tree's DBH, and then we can calculate the base area per hectare. Now we can see some results. First, we analyze it not only in the density of the overall trees, but those trees with we call the large trees. Those trees has a crown diameter larger than 10 meters. So as you see, with the distance from the center, we found the tree density increase, but the density of large trees decreased, and the tree canopy cover decreased. On different region, we can see in the rural area, the tree density is very high. And in the urban area, the large tree density is high, but the overall tree density is lower. And then we'll look on the tree size. Here we're focusing on the crown diameter and the DBH. So from the with distance from the city center, we found the DBH and the crown diameter decrease. And if you check out in different region, we found in the urban area, the tree crown diameter and DBH are higher than the rest of the place. And now there are more the maps and the detection results. So let's take a look at the detection results first. You find it on the figure E, figure F, and the figure G. They are from the different regions along this gradient. So we can really see the tree crown are very large in the urban area, but the density is low. In opposite, if you go to the rural area, you can see the tree crown is very small, but the density is very high. And you can also check out the maps we made along this gradient. Only the tree density, which is the figure A, they have a large tree density, which means the pixel darker in the rural area, but the density of large trees and the tree crown area and the base area are all larger in the urban area. So here's some conclusions. So in this study, we use a deep learning model to detect around 1.3 million trees along this gradient. It really highlights the potential of those deep learning models for mapping trees at the individual tree level. Beyond the canopy, we built an allometric model for the DBH prediction using the crown diameter, which is very crucial for the trees outside forest mapping on the biomass and the carbon dioxide. In the Bangla, we found along this gradient, the tree density is increasing, but the tree size and the tree canopy cover decrease. That can be explained by several factors, such as the different growth patterns to the trees, to the environment trees, and also more importantly, because different ecosystem service provision and also different the management practice. Okay, that's all for my presentation. Thank you.
Thank you, Tom. That was even less than 10 minutes. Great. So we have time for a number of questions. And you might ask questions for clarification or of application or whatever. It's a methodologically slightly demanding topic, I would say. Who wishes to start with a question? Yes, please. Just when you ask your question, please first identify yourself. What's your name? Where you are from? And I mean,
Yeah, sure.
yeah.
Hello, hello everyone. This is Rama, and I'm doing my PhD in ETH Zurich. Yeah, so it's a nice talk. I was just like wondering, the outskirts of like the rural areas of Bangalore, which you compared, it is known as to be a semi-arid region. So the rainfall is something which is like very low, like 800, 700 millimeters of rainfall. And I was like wondering what's the rationale behind comparing the urban area and the rural area, given the fact rural areas are not like the rural area which you are compared is something which is predominantly grasslands or shrublands. And I was like wondering what's the rationale behind comparing a city which is promoted like tree planting and an urban area and a rural area which is not suited for tree plantations and like trees. Did I put it clear?
Yeah, I think, can you hear me? I think so, yeah. So,
Okay, you have your mic on.
yeah. So I think the question is about the rural area and urban area. So, yeah. Sorry. Yeah. So I guess you're right, because we don't know exactly the boundary between the rural area and the urban area. So in this study, we just used to actually before this study, we conduct some research to classify the built-up areas, and then we use the built-up areas to decide which area is the rural, which area is the urban area. So in our study, we find if the built-up areas large 50%, we contribute to the urban area, but if less than 10%, we assume it is the rural area. Yeah. Thank you.
Yeah, it was mainly learning about the gradients, the differences between rural and urban areas, because many of the rural areas around the urban areas will be urban areas in the near future. And tree management is quite an important topic in Bangalore, which was called some time ago the Garden City of India. And that is the reason why the big trees are in the center and not in the outskirts. More questions? Yes, please.
Thank you very much. It was a nice presentation. So, my name is Polash. I'm a PhD student at the University of Kassel under Professor Tobias Klininger. So, I have just a simple question like, how do you define tree outside forest and urban tree? I mean, is there any specific category which tree we would call like outside forest? There are many gradient, rural gradient, agricultural gradient. So how do you define these two terminologies? Thank you.
Okay, thanks for your question. Actually, it's a very good question about the definition of the trees outside forest. So here, the trees we detect, we all consider the trees outside forest. But those trees can be found in the urban area, which we used to call it the urban trees. And if those trees found in the rural area, like if they planted on the agricultural land, we also call the trees outside forest. But of course, they have another name called the trees in the agricultural system, also trees in the agroforestry. So I would say the trees outside forest, this concept is larger than the urban trees. It includes the urban trees.
That's a very good question. I mean, And we can answer it very simply. Trees outside the forest are all trees that are existing in non-forest land. But then the question is, how is forest being defined? And India is one of the special cases, like several other countries, where there has long been and possibly still is a legal definition of forest. So there is forest land. This is legally defined. This is forest, be there a tree or not. So it may be that we have a forest land, but there's no tree. It may be that we have a large accumulation of trees, which we would call forest, but it's not on forest land. So that is then called trees outside the forest. Very confusing, but we are adhering here to the biophysical definition of forest with a certain density, a certain minimum area, and so on. Okay. Next question there, but I would also like to ask our online participants if there are questions, just indicate that somehow or start talking. And then we can include your questions also in our discussion. But now I would like to start with this lady. No, in the very rear, not you, not you. Okay, so number 2, number 3, okay? Sorry.
Yeah, just a short question. So what are the effects of tree density, increase in tree density and decrease of tree size and the decrease of tree canopy? But maybe that's a bit too broad to answer now. But
Can you speak up a little bit? It's difficult to hear.
okay, sorry. So you mentioned that the outcomes of your research are tree density increases, tree size decreases, and tree canopy decreases.
Yes.
And I'm a complete layman in the world of trees. So could you maybe explain a bit in short what the effects are of these outcomes?
So the effects or the reasons why this happened is the question. Yeah. So I think there are more trees outside forest, but they are managed by the different purpose. Just like the tree in the forest, in the urban area, we really don't need the timber or fruit, anything else. Maybe we just need the huge tree crown to get the to mitigate the heat. But for trees in other landscapes, like trees in the agriculture land, they planted for the purpose there. Like they could mitigate the wind and also for the sheltering. But more importantly, like trees in the plantation, they will be planted for the products like timber, like fruits, and other things. So they are really managed by different purpose.
Yeah.
So just like in the plantation, the trees should be planted row by row, and then there's a space between them. And normally, if the tree is only for the timber, the tree crown wouldn't be too large, because they have to plant more trees and get more timber. Yeah, something like that.
It's very difficult to talk about effects of these trees, but we may talk about the functions. And that's more of an ornamental type in the urban context and more of a production type in the rural context. And now I would say short questions, short answers, because we are running out a little bit of time and we do not know how much buffer we have. I think you were number 2, no, behind you, and you were number 3, or whoever.
Okay. I'm Franklin Meyer from the University of Hohenheim. I don't know if I didn't understood it or just missed it, but I have a question about methodology, because you're speaking about aromatic models and the combination of the crown size with the circumference of the tree. And I'm just asking, this is a ratio which is like quite species dependent. Did you train the AI also for the species, or is that still too early to do?
Okay, that's actually a very good questions, because you're right. If we start from the elementary model, including the species is very important. Maybe we'll totally change But unfortunately, in our stage, in this research, the model we trained now is unable to get the species classification. But in the future, if we train a model that include the species, but of course that will require our labeling, which we need to label trees on the images, which is now it's kind of hard on the satellite imagery. So in the future, we can do that, and then we can get the not only in the tree crown, we can also know the species of the trees, and then we could develop more sophisticated allometry model to predict the DPH to get the biomass more accurately. Yeah.
Okay, and now the last question, please.
Thank you, Malena. I'm the Ecuador and I'm a student at university. It's like the same question, but just one comment more. When you say you measure individual trees and you create a metric model, you register also the pitching, or it's like.
Yeah, it's kind of same question, I think.
Yeah, the model doesn't consider then the species, just
Yeah,
like.
Not yet. Yeah.
Okay. Very good.
Yes, species identification by remote sensing is a very intensively researched topic at the moment. And it works for some species and for others not. We did it with a very good result for palm trees. That is working nicely, but for other tree species, not so much. I think we need to break now the discussion here, but Tao will be available. Thank you very much. Maybe a little applause again for Tao. And we are coming to the next presentation that will be given by Dr. Tiwari from India. And this is on an interesting topic, that is incentives for tree planting. And let me make a brief comment. India is quite good in incentives for fostering tree plantations, and now obviously also for tree planting. The idea to plant trees wherever we can plant trees is not new. You might know about the famous works Silvicultura Economica, where Carl von Carlowitz in 1713 was supposed to mention for the first time the term sustainable. Was not the first time, but we all believe that it was like that. And he wrote in his book, we should plant trees wherever we can plant trees. So the idea is not new, but still the incentives need to be there to bring that on the ground. VP.
Good afternoon. I'm going to present about the recent initiative of Government of India to improve the tree cover and address the climate change issues. And also it is related to the environmental protection of our country, that is known as Green India Plan. So just because this is a very innovative idea by the Government of India, so I thought that I should inform the audience about this plan, and it may be helpful to the other participants from different countries. Because India has various commitments, and it is really committed for the large-scale forest production and tree-based landscape restoration. And in the bold commitment, India committed to restore about 21 million hectares of the degraded and deforested by 2030. And then we increased this target when there was a COP14 meeting in New Delhi. Then this target was increased to 26 million hectares of the degraded and deforested land. Yes, I want to inform that so far, till there was a Government of India report in 2018, that we have already restored 9.8 million hectares of land. And as on today, out of this commitment of 26 million hectares, Government of India has restored almost 22 million hectares of land. But we need to restore 4 million hectares at least more to fulfill this commitment by 2030. That's why this initiative has been launched. In India, we have about 94.6 million hectares of land that is degraded. And this is really near about 30% of the total geographical area. So 30% of our area comes under the degraded land. And we have also national determined contribution. There the commitment is to improve the forest and tree cover and to sequester about 2.5 to 3 billion ton of carbon dioxide equivalent by 2030. So if we want to achieve this NDC goal, then we need not only to protect and improve the cover, but also to extend the tree cover to by 25 to 30 million hectares in the mixed land use system. And just to fulfill this commitment, and extend the tree cover from 25 to 30 million hectares, and Government of India has launched this program. And this initiative was taken by government only in the October 2023, so it is very new. And we have already an Environmental Protection Act 1986. Under this act, this initiative has been launched, where we will build an inventory of the degraded land that can be utilized for the environmental purpose in our country. And the emphasis is to train the people to develop business using this green carbon credit program to focus on pro-planet people. Actually, it is an innovative market-based mechanism where any individual or entity can go for the plantation activity and they can earn a carbon credit. And Government of India will start a domestic trading platform where they can trade this type of carbon credit. They can get from this GCP. And actually, when there was in 2022 COP26 meeting was held, Government of India and our Prime Minister, they have committed for the lifestyle and environmental conservation, which is part of Life Initiative. And based on that, this GCP has been started. And the main goal is to lay emphasis on sustainability, reduce waste, and improve our natural environment. And the aims are to enhance India's forest and tree cover, to build an inventory of the degraded land under the control and management of state forest department that can be afforested, and to encourage the people and different entities in the pro-planet action by rewarding the green credit to them. There are several important activities covered under this green credit program. One is tree plantation, where we are going to plant trees to increase green cover and combat deforestation. Then there will be water management, and strategy will be to efficiently manage and conserve water sources. Then sustainable agriculture, where we have to promote the eco-friendly and sustainable agriculture practices. The other is waste management. We need to have implement effective waste management system to reduce environmental pollution. Then the fifth one is air pollution reduction, where the aim is to reduce air pollution and improve air quality. And the last initiative is mangrove conservation, where we have to protect and restore our mangrove ecosystem for the ecological balance. There is already set guidelines for the governance and administration of this green carbon credit program. So where it will be facilitated by an administrator or nodal agency. And Indian Council of Forest Research and Education, Dehradun, they have been nominated by the Government of India as the administrator or the nodal agency to facilitate this application. And ICFRE will be responsible to oversee the financial contribution, which is directed for the forest revolution. And this will then extended to the concerned state forest department. This plantation will be completed within 2 years, and after that, the ICFRE will conduct an assessment of the planted trees in that particular land parcel. And once this evaluation is done, and based on this evaluation report, each single tree will be assigned 1 green credit. And for that, the Indian Council of Forest Research and Education, ICFRE, will start a registry program where any entity or individual or the corporation, NGO, they can register their plantation through that website, and then verification will be done, and then a trading farm will be started by the administrator where they can trade their credit which they have earned through this green credit program. The significance of this program is that this is aligned to India's environmental policy. We have environmental policy like Environmental Protection Act and 1986 and the National Environmental Policy 2006, where we have the framework to protect and improve the environment. So these policy alongside this, the newly launched Green Credit Program it is aimed to safeguard forest wildlife and overall natural environment. Then it is also aligned to the India national climate goal, because in COP26, many commitments were made by the Honorable Prime Minister of India that we have to go for net zero emission by 2070. There will be renewable energy will be 50%, renewable energy 50%, non-renewable energy, and then the non-renewable energy we have to generate at least 500 gigawatt by 2030. So that is the commitment made in COP 2026. So this GCP is also aligned to the commitment made by India in COP 2026. And also this will broaden the scope not only for the carbon credit, but beyond the carbon reduction, and it includes a wide range of the sustainable production. And then it is also aligned to the global eco-restoration initiative. We all know that we are under the Union Decade of Ecosystem Restoration from 2021 to 2030, which emphasize on the scaling up of restoration effort, and this is also a part of that initiative only. And here all stakeholders will be involved in the restoration approach, and it will leverage the traditional knowledge and consumption practices. The methodology of this Green Credit Program has been launched only in February 2024, few months back. We have 6 main initiatives under this GCP, but the methodology has been given only for the one component, that is tree plantation. The methodology is that State Forest Department, they will identify the degraded land parcel under their jurisdiction, which is free from any hindrance and available for the person. Then they will report that land parcel to the ICFRE, and then ICFRE will ask from the different entity or individual to submit proposal for the Green Credit Program. And once proposal is received by the ICFRE from any individual or any corporation, any entity, then ICFRE will ask them to they will assign the available land parcel to that particular entity or individual, and ask the individual to submit a proposal for the plantation. And once this proposal is received, then ICFRE will send them a note where they have to submit the amount required for the plantation on that particular land parcel. Once that money is transferred by the individual or by the corporation, by entity to ICFRE, then ICFRE will ask the concerned forest department to go for the plantation on that particular land, and 2 years will be given. Where after that 2 years, SFD will report the ICFRE that plantation has been completed. Then ICFRE will verify, identify and report about the plantation, and once it is verified, then one carbon credit will be added to one individual tree. And the criteria is about that 1100 trees per hectare should be there, with reference to the soil and climatic condition. And then, but there are many challenges. It will impact the forest ecology. Then there are methodological concerns. So the way forward is that to address these challenges, we need to go for biodiversity-based afforestation, where we need not to go only for tree count, but we have also to consider herbs, shrubs, and grasses. Then technology integration is always there, because our department is reporting the land parcel under the register based on the field budget, but no technology has been integrated. And there is 2 terms, degraded land and wasteland. When we are merging these, like pasture land, grassland, they are also comes under wasteland, but when tree are planted there, then there is ecological imbalance. So we need to differentiate between the degraded land and wasteland, and then of course the knowledge sharing and capacity building are always there.
Time is over, so we have no time to continue.
And we have finished. Now I have also finished.
Okay, you're finished.
Yeah.
Okay, so we can start the discussion.
Yeah.
Sorry for interrupting. Thank you very much, VP. Let's maybe first ask whether there are online questions from the online audience. Can you please indicate whether you have questions? So we have 7 online listeners, or at least 7 are listed. Well, there appears not to be a question. So we might start here with our round of questions. Any questions to VP Tiwari? Maybe, okay, Mary.
Thank you very much. Thank you for your presentation. I'm Mary Logan from Key University in Göttingen and from IPB University in Indonesia. This seems like a really fantastic success case. I mean, it's the UN Negaran ecosystem restoration, but in fact, yeah, in many cases there are barriers to tree planting and to such successful cases. Can you talk some more about really what you think contributes to, India really having the capacity to scale up such planning processes, and you can talk more about.
Thank you. Government of India had different program. Like we have also Green India Mission. In Green India Mission, Government of India had $4,600 million for the afforestation, where the company, because we are diverting the forest land for the non-forestry purposes. And when land is diverted, then that concerned company had to deposit some money with the Government of India. And then that money is being given to the State Forest Department to go for afforestation on the open lands or the scrub lands like this. So under Green India Mission, lot of money is available. And that $4,600 million is huge money. And as I told you that out of 26 million hectares of work, we have already restored 22 million hectares of land as per the bond commitment. That is already over. And here under this program, it has been launched very recently. I told you Masraji has been launched only in February 24. So it is only 5-6 months old program. But already State Forest Department has identified 237 land parcels, that is nearly about 17,000 hectares of land has been already identified in 13 states of India. And under this program, very soon the afforestation will be started on those 17,000 hectares of land. And this will be distributed in 13 states of our country. But apart from that, we have also solar energy mission. We have a mission for the agroforestry. Lot of missions are there. And it is very difficult to summarize in 2-3 minutes all those missions. But it has been taken in very gigantic way by the Government of India to address the climate change issues.
Okay, thank you very much. Maybe a short question in between, following up to my comment on the last presentation. Can this reforestation or tree planting be done everywhere or only on forest land?
No, it can be done everywhere. Because now under this program, State Forest Department has been asked to identify the degraded and wasteland. They have not included the term forest land. So it is degraded land and wasteland. So any degraded.
So it's not forest land.
Yeah.
So for you, it's trees outside forest that you are planting.
Yeah.
Okay. That's a little bit confusing to me. Okay, yes, please.
My name is Vishwa Mahindra. I'm a PhD student in the University of Missouri. You have mentioned a lot about afforestation, but there's a lot of deforestation happening in the name of infrastructure development. And I think at the stage that the world is at right now, it is very important that those forests that exist in whatever form need to be preserved. Are there measures being taken? Because I am from India and I do know that a lot of projects are going on where they're cutting down a lot of forests, a lot of trees. So are there measures being taken to combat these things that's happening in the country?
Thank you. I think you are Mr. Mahendra, I think.
Please afford to reply.
No, measures have been taken. Government has mandated if you cut one tree, then you have to plant 10 trees. That is one measure taken by Government of India. So it is not so easy to cut the tree. And once that land is diverted, because like in hill area, we have to make roads. So we have to cut the tree. For that, any company which is taking the development projects, and they have to divide money and under Green India Mission, then afforestation will be done. And if you see our recent data, now from 2019 to 22, you see FSI report, now presently we have tree and forest cover 24.62%. So 2.91% is the tree outside forest, and 21.61% is the forest cover. So during last 2 years, 961 million, 61 kilometer square forest has been increased during last 2 years. So definitely those measures have been taken.
Okay, thank you very much. And now I hear that we have an online contribution or online question.
Please tell him to share the screen.
If you could please share the screen. Who is it? Mitiko. Mr. Mitiko, would you please ask your question or make your statement or comment?
No, you can share the screen like, because there are no questions. There are no questions, please tell.
Oh, there are no questions.
Yeah.
Okay, so thank you very much, VP. Our time for questions is over, but VP will also be here for the day and tomorrow, so you can contact him for questions. And now we are coming to the next presentation. And that will be by
Like he's available. Can you ask him, Mitiko? Because
Okay.
Okay, yes.
okay, sorry, wait a minute, because now obviously the question is coming. So, Mr. Mitiko, please ask your question or make your.
He's going to present the next, because he's the online one. He's the first one, I think.
Okay, so he will do the presentation now. Yeah, now we are somewhat in a time issue, no? Okay.
Okay, thank
Mr.
you.
Mitiko,
Okay, are you hearing me?
you need to be very concise in your presentation, and we have not much time for questions afterwards because we thought that you will not be here. So please start with your presentation and we can hear you and we will listen, please.
Okay, thank you very much. I'm very happy to be here. I am Mitiko Ayele Handiso from Ethiopia, from Southern Agricultural Research Institute. I'm currently an associate agroforestry and soil management researcher. I'm going to present my research, which is entitled Effects of Canopy Management.
Mr. Mitiko, can you speak up a little bit? We have a technical issue here that we have a hard time to listen to you, to hear you, because the voice is very low. So try to shout.
Okay, I will try. Okay. My name is Mitiko Ayala. I'm from Ethiopia. Currently, I'm an associate agroforestry and soil researcher. I'm going to present my research result, which is effects of canopy management of umbrella tree, which is called terminal abroni, on microclimate and the yield of maize under parkland agroforestry in southern agriculture in southern Ethiopia. Okay. So, okay. It is visible. Not the next slide is not going.
Please press.
Okay. Now. Okay.
Please press if so that you have the full screen. Please go to presentation mode.
Is that okay?
No change so far.
I think my computer is busy now. It is opening. Please wait. Okay, it is okay, I think.
Yes, now it's better. Thank you. And
Okay.
try to speak loudly, please.
Okay, agroforestry parkland is a system that is the trees that occurred in croplands deliberately, either from remnants of forest trees or domesticated trees on the farmlands deliberately by farmers for to consume to multi-purpose uses. In Ethiopia, particularly in southern Ethiopia, this practice is already practicing by indigenous farmers of smallholder farmers. However, its management effects on microclimate and the maize yield is and productivity yet been not scientifically quantified. Even the studies was done on other trees is indicates the result indicates contradicting results. For example, here the first one, those two research results indicates the result highest crop yield found under edge of the tree canopy. When we come to the third, the both under first result is found under near the tree canopy. That means near the tree trunk. The third one is those almost all those mentioned under found the highest yield out of the canopy. Those both are their evidences. The open field, the highest yield is received on open field due to the canopy effects. Also, the other factor is the farmers' perceptions on that trees is also as a barrier for plowing. In Ethiopia, traditionally plowing is by oxen. For that, those trees, farmers perceive those trees as a barrier, and those affects the crop yield due to the canopy. So some farmers practices by pollarding to minimize this effects by pollarding and pruning. But those indigenous farmer knowledge is not scientifically integrated. So this study is very important. The objective of this is to investigate it is canopy management on microclimate and the maize yield and the yield component is hypothesis is the highest. This is here is the research was done. First, research on their dominance and preference of those trees that found on farmlands is based on that this Terminaria browni is selected purposely. But the sample trees was selected based on near similar DBH, crown radius, and height, age, so on. Here is two factors, experimental design. First one is tree management. The second one is tree radial. That means the distance from the tree trunk. This we divided into three. The first one is near the tree trunk. The second one is each of the canopy. The third one is open. The tree management is pollarding, and the second one is pruned. The third one is control, neither pollarded nor pruned. This is the structure of the layout of the schematic layout of the experimental design. Under each trees, those three radial distances drawn under pollarded, pruned, and neither nor pollarded. Then after all crop yield and the yield component and the soil yield or microclimate and all data were collected from those three plots. After the collection, those collected data were analyzed by using ANOVA model and mean separation to separate the result, when we come to the result part, let me go to the result part. The first one is microclimate. When we see microclimate, the highest soil moisture content, the highest soil moisture content is found under controlled under the controlled tree and open near the edge of the tree, because that plot is no competition, no the evapotranspiration, no minimum evapotranspiration. Due to this, the highest moisture content is found here. The second one is soil temperature. Soil temperature is the highest soil temperature is found in open fields under pruned, pollarded, or neither pollarded as control. The here, when I come to the yield and yield component is the highest yield is observed at pruned and pollarded at D2. That means at the edge of the tree canopy.
Mr. Mitico, Mr. Mitico, I'm sorry, I need to interrupt because the 10 minutes are over and we still want to have one or two questions, so we cannot have more of your presentation. If you have one final concluding slide, please show it.
Okay, thank you.
The quantity of information that you wanted to present in 10 minutes is quite challenging.
Okay, here is the final conclusion. The soil result indicators shows the highest soil nitrogen and organic matter is found under tree canopy, and the lowest is open field. When I come to the crop yield, the highest yield is found, as I said before, the highest yield is found at canopy at the edge of the tree canopy, due to the grain yield, the minimized canopy effects on that. Because the microclimate is affected by canopy management. Thank you very much.
Thank you very much. In the interest of time, I suggest that we have one short question and one short answer now.
Okay.
Yes, please.
Thank you very much for interesting presentation. My name is Thương. I'm a PhD student from Swedish University of Agricultural Science. So my question is, do you consider the sun direction in this study, and you measure how difference in terms of radiation in three different canopy controls?
Okay, simply the three radial distances was drawn under three canopies, those pollarded, pruned, or neither pollarded or pruned, that means under control trees. That is based on the canopy divided into two. For example, if you see the schematic drawing of the plots, here is
that means that you took into consideration also the question of illumination, and that I think that was the major issue, right?
Yeah,
okay.
Yeah.
Thank you very much. And I think we need to close that now with another applause.
Close this satisfying.
Okay, Mr. Mitico, can you please? Yes, you closed your presentation. Thank you very much. And
okay.
Now we are coming to the next presentation, which is a very typical agroforestry presentation, where it's about the benefits for livelihoods and the benefits for the environment. And we are now going from Ethiopia to the Ivory Coast, and Hannah Celine Caminada is presenting on a topic that I think we all noticed, that chocolate is so expensive now. And she is talking about cocoa agroforestry.
Yeah.
Okay.
Okay. Okay, yeah, my name is Hannah, and I basically want to present a few of my findings from my master thesis that I did with SALF, with Götz Uckert and Stefan Sieber from SALF. And I want to start with showing you this picture and just like invite you to have a few seconds to have a look at it. And yeah, so what do we see? I mean, I think some of you would think it's a bit a disturbing picture. But besides this, what I want to get your attention for is that we see a bunch of happy farmers. They're smiling, and they're standing in the middle of some quite healthy looking plants with prosperous yields, with a lot of cocoa beans on them. So that means they have actually all reason to be happy. But in fact, that's actually not like agroforestry looks like often. So for my master thesis, I went to Côte d'Ivoire, and I had a look at the agroforestry system there, and it looked quite different in reality. We're facing many threats there. There are around 80% of all farmers facing high levels of poverty. Then we have a lot of environmental threats such as climate change and soil deterioration. And then the production system itself also contributes to deforestation, so that we have importing partners such as the European Union, for example, that strengthen their requirements and bans, so which makes this agroforestry production system, how it is now, basically not much longer feasible. So the good news about this now is that there is a solution that can basically address all of these issues. The only problem with this now is that organic fertilizers, even though they exist in Côte d'Ivoire, they're often not really applied in cocoa farming. So we don't really know how we can make farmers apply organic fertilizers yet. But if we think about it, what we do know is that there are individuals that take the decision whether to apply organic fertilizers, whether to supply farmers with them, whether to produce them. So we figured if we understand the individual's behavior, we can maybe manage to link organic fertilizers to cocoa farming in Côte d'Ivoire, and therefore kind of try to move agroforestry in Côte d'Ivoire a bit closer to this initial picture that we saw. So that was also the aim of my research. I split this up into two questions. So first, I wanted to understand how fertilization behavior is formed in general, and then maybe come up with some implications how we can use this knowledge to upscale organic fertilization in the sector. So how did I do this? I applied Q methodology. I don't know if you're familiar with this method, so I will quickly explain it. So basically, respondents get this grid or a similar grid, and they get a set of statements, of opinion statements, and they're meant to sort these statements into this grid according to their opinion from fully agreed to least agreed, and comment on it so they can really display their whole opinion on the topic. Q methodology typically follows these 4 steps. I don't want to bore you with my methodology, but I will quickly walk you through them so you kind of understand what I did. So I basically needed some opinion statements to give to the stakeholders to sort them in the grid. And I used a systematic approach for this. I had a framework which offered me some categories for environmentally friendly decision-making, and I filled these categories adapted to organic fertilization decision-making with some insights from the literature and also from expert interviews. And this way I came up with 40 statements. These 40 statements I presented to 39 participants from 5 different groups. I basically selected these groups after their impact on the fertilization decision. So I found some farmers that basically take the fertilization decision. Then I interviewed cooperative representatives and associated people to organic fertilization businesses that supply farmers with knowledge and inputs and therefore influence the decision. And then I also talked to agricultural consultants and researchers which supply farmers with knowledge. So then I gave my 40 statements to my 39 participants. Each of them sorted the statements into the grid, as you can see here, some examples. And this way I came up with 39 different perceptions on organic fertilization in Côte d'Ivoire's cocoa farming sector. While 39 was a bit too much to work with, a bit hard to handle. So on my next step in the analysis, I basically tried to statistically attract the most common perceptions on the issue, and then describe them with my qualitative data that I collected during the interviews. This way I found 3 different most common perceptions in the sector. I don't have the time to explain each of the perceptions I found, but these 3 perceptions basically differed in the majorly represented stakeholder groups. Then they had different overall character traits I could kind of identify, and they also differed in the specific decisive reasons that individuals had for or against the decision whether to apply organic fertilizers. I was also able to identify 3 major areas of action that could basically tackle the constraints I found in this study. And they are adapted training and knowledge dissemination, increased cooperation, and tailored incentivizing payment schemes. And yeah, probably for those people of you who are kind of familiar with the topic, that still sounds a bit broad. So what was interesting in my study was that I actually know the specific individual needs, so I could adapt these areas of action even to those needs to make them more expedient in the end. I don't have the time to show you with all of these areas of action how I did this, but I just want to quickly illustrate it with the area of adapted training and knowledge dissemination to kind of show you how behavioral insights help to come up with specific policy implications. So I assume that most of you would agree that the goal of training and knowledge dissemination commonly would be to match perceptions with reality. And what we got from my study is that we have different knowledge needs in the sector. We have different stakes of different stakeholders in the issue, and we have different preferences of receptance of knowledge. So how can we include this into our recommendations? Well, we have to target knowledge dissemination production only to those areas where there is no knowledge currently, so where there is no knowledge in either of these viewpoints, and that would be more economic performance research into different organic fertilizer options. Then we want to enhance the dissemination of available knowledge in those areas where current states of knowledge are differing between my different viewpoints. So we, for example, found this red viewpoint there. They have the least amount of knowledge. They often don't even know what organic fertilizers would be good for, while the blue viewpoint knows really well what organic fertilizers can or can't do, and we kind of want to equalize this level of knowledge. So we can do this with upscaling knowledge dissemination, but we also need to optimize the tools to kind of reach all viewpoints the same. And we have 3 different viewpoints, and with this we also have 3 different preferences for receiving knowledge. So we have digital tools that are most liked by the screen viewpoint, then we have field demonstrations, and the red viewpoint asks for closer accompaniment. So if we kind of incorporate all these tools, we can most likely reach a larger target group than we do now. So I basically did a similar procedure for my other areas of action that I've presented before as well, and could this way kind of target all the constraints I found, which kind of shows us that we actually this way managed to understand fertilization behavior a bit better, and that this actually helped to link together organic fertilization and cocoa farming, and possibly may also help to reach a picture that looks a bit happier, a bit more like this. And it also shows that including behavior into policy making does make a lot of sense. Q methodology was quite suitable for this. So we recommend to maybe also mainstream this approach for other sectors for promoting sustainable agroforestry. Okay, thank you.
Very much, Anna. So I'm really excited about the diversity of topics that we are covering here in this one session. Other questions, observations, requests for clarification? Or are you just tired? Yes, please.
Not a bit, just a comment. I was really impressed with your methodology section and how you have involved different stakeholders from farmers, cooperative members, researchers, and in one more category. But there are a few, just a suggestion, there are a few cooperatives in a few different other countries where they are now moving towards a more sustainable approach. Like I think in Netherlands, it started a few years back, they're called environmental cooperatives. And probably reading a little bit more about them and maybe interviewing a few of them could actually add to solutions. Great presentation.
Yes, thank you for this comment. I didn't really. Okay, yeah. So basically what restricted me with my cooperatives and farmers was the project that I did my thesis with, because I was working only with farmers and cooperatives from the project. So the study was not representative for the total population. But yeah, we were also trying to find what constraints the farmers from the project, because it's linked with training offers based on what we find there. So that's how we selected them.
Thank you. One more question, Mary, please.
Yes. Okay, thank you so much for the presentation. I'm not sure if this is as much the case in the Ivory Coast, but I know in many cacao producing countries, it's not often the farmer, but more the landowner. And this is not often the same person, right? So in the Ivory Coast, or in the cases where you were looking, is it the farmer themselves who can make the decision of which fertilizers to use, or does it come more from the landowner, or who in that kind of chain of, yeah?
Yeah, I had also heard this before, that could sometimes be the case, but in fact, we actually asked all our farmers that we interviewed, and actually all of them were landowners. So they can actually take the decision, but a lot of farmers belong to the group that I found that don't really have the knowledge about it. So they really often just don't consider the option of applying organic fertilizers.
Okay, thank you very much. I think we need to close the discussion session now. Thank you very much. Anna, maybe another applause for her. We are coming now a little bit behind our schedule to the last presentation from Basiro Boyan. And this is an online presentation, and I'm curious to see how it works now. Mr. Boyan, are you there? Can you hear me?
His name is not here, maybe he is with another name. His name is not here.
Maybe the co-author, Mr. Yaku Chantu. Okay. So it appears that our last presenter who would have presented online is not there. And that means that we are now coming to the general discussion, wrap up and closure of this session. And if there are more questions to the former presenters that I killed during the discussion, because I believe that we have no time, ask now. Okay, I understand that. And my wrap up will be a very short one. I was a little bit nervous before this session because we had such a mixture of different topics, but I found it really great to see, to have a look onto trees outside the forest, which is not forestry, from very different perspectives. And not all of these perspectives are my perspectives in a technical sense, but I found it really interesting. And I would like to thank all our presenters, and maybe you join me with this. Thanks. I would also like to thank you, and thank you very much for your contributions to the discussion. And I now close a little bit prematurely this session and hope that you are not very sad about that. Thank you very much for listening.